So sorry folks for sitting over there. We actually will be doing it from this side. So if you guys want to move over. Hello. Hello folks, welcome all. A lot of new faces and some familiar faces from the past meetups. Really good to see all of you coming. We just some logistics before we get started. If you want to go to the restroom, you will exit from this door and turn right, and you'll see a restroom sign over there. And there's a Wi-Fi information written on the board on both sides if you want to connect your devices. So we have two talks today. The first talk is on AppSync. It's a very hot topic, GraphQL. And we have Steve Johnson from AWS, who's going to be talking on it. He is a solutions architect and solution principal architect in AWS for the last 5 years. And he's coming all the way from Orange County. So give him a big hand for coming here and presenting this. Sorry?
You have more to say?
No. I'll leave the rest to you. Hello? You guys did this? No. Hello? Okay.
There you go. All right. Okay. I'm now amplified. Very good. Okay, welcome everybody. My name is Steve Johnson. I work for AWS as a solution architect. I'm a specialist in mobile and digital user engagement. And one of the products I work a lot with our customers is something called AppSync. And even though I can talk in depth about AppSync, in a nutshell AppSync is a managed GraphQL service, okay? And just to make it more interesting for everybody and not like a marketing speech, I want to talk a lot about GraphQL, and then we'll look at AppSync as far as how it implements GraphQL, what's different about the spec versus the implementation that AWS has, that sort of thing. So let's get started. And of course, I'm going to start with a shameless plug. reInvent's coming up in 2 weeks. Is anybody going? Oh, all right, fantastic. I won't see you there. There's like far too many people. But if you want to talk about mobile and you want to track me down, let me know, and I will make an effort to see anybody who's there, because it is actually, Andy Jassy, frames it as a training conference more than anything else. And it is a training conference. If you don't work for AWS, if you work for AWS, it's sort of like if you were an elf in Santa's workshop, this would be Christmas. So yeah, just picture AWS employees going crazy with their hair on fire for the next 2 weeks. So you get that to look forward to. All right, so let's talk about GraphQL a little bit. And has anybody used GraphQL in the room? Okay, at least one person, good. So I'll start with a little bit of history here. GraphQL was developed by Facebook back around 2012. They started working on it internally, and they released it to the public 3 years later. and it's now under a nonprofit organization called the GraphQL Foundation, which is part of the Linux Foundation. So all that is to say, Facebook invented it for their own use cases. They thought it would be very useful for other people writing high-performance web applications and mobile applications. It turns out they were right. And it's an open standard now. So other companies, such as Amazon or Microsoft or anyone else who's interested in GraphQL, can build their own implementations, which of course AWS certainly has. So GraphQL is a specification more than anything else. If you take a look at the documentation on GraphQL, 90% of the specification is syntax, right? Basically, how do you construct queries, how do you construct schemas, how do you construct all the different parts that go into a GraphQL document, right? It doesn't talk very much about implementation at all. In a way, it's sort of like a white paper with a lot of syntax details. And it's really up to the implementer to figure out how this is going to work and whether it's going to be performant and to what degree it scales and all the good things we expect out of web technology nowadays. I think it's, well, before we get to that, it's not related to graph databases at all, unless you want it to be. And what I mean by that is when Facebook first came up with the name for this GraphQL, obviously as a social network, they have huge graph databases at Facebook. So it made sense that they would be querying their graph databases and other things with this language. When I talk to customers, a lot of people think this spec is actually tied to graph databases and backends, but the truth is you can put whatever backend you want behind a GraphQL server, right? So that's something that's important. And the last thing is, if you're not familiar with GraphQL, it's useful to think of it as analogous to SQL, right? Like GraphQL and SQL are both languages. They both allow you to query data sets. But probably the most important difference is, as I mentioned before, GraphQL doesn't specify what the backend looks like or what type of data. You could be querying flat files or, I don't know, whatever, quantum binary trees, it doesn't matter, right? I just made that up, maybe I'll patent it. But what's also interesting about SQL, especially with certain providers, it is actually becoming sort of like a lingua franca for querying things. Since everybody knows SQL, it's a good starting point for a lot of things like, for example, in AWS, the IoT service has a query language for IoT that's actually based on SQL. So I kind of see GraphQL may actually go that way. Hopefully it does become widely adopted because I think it's pretty useful and very flexible. Okay, so Facebook describes it as a query language for an API. And that sounds a little interesting. And what they mean is, it's a different way of looking at writing an API. So if you're doing, let's say, a RESTful API, which is probably almost definitely the most popular way to do a web-based API right now, you know what to expect in terms of implementation, right? You're going to have resources in your URIs, right, that identify resources on the back end. You can get individual things or lists of things. And your query, I should say your API is generally defined by these URI endpoints, right? In GraphQL, you don't have a URI to point you at a certain method, right? So you don't have multiple endpoints to point to. You're literally connecting to a server, okay, over sockets or HTTPS, and you're sending it a document and expecting something in return, okay? One of the great things about GraphQL is the shape of your returned data matches your query. So in other words, when you send that document, that query document, to GraphQL, you can expect the data to come back in exactly that format, right? And we'll get into more detail about how this works and what it looks like in a minute. The other thing that's useful is because this GraphQL implementation sits on top of your data stores, it acts as an abstraction layer, okay? So you can construct your implementation of a GraphQL-based database to say, okay, I want this query to actually point to these 2 or 3 or 10 different data sources. And of course, there's work involved for you. It's not magic, right? You still have to write what's called resolvers to pull this data. But as far as users of the API, they don't have to worry about that, right? All they know is they're asking for a certain amount of data, they'll get it back regardless of where it's from, okay? And lastly, and this is something that's quite a different way to look at APIs, we don't version them, right? Your GraphQL API basically evolves over time, right? And what I mean by that is, when you write, let's see, next one. When you write a RESTful API, for example, right? And let's say you want to look up, I don't know, all the books in the library. You might have one request that says, give me all the books in fiction, right? And there's very little flexibility in a REST API in that sense, right? In that an individual call from a URI is going to give you either a list of things back or usually one thing back, right? And although that becomes a very efficient pattern for designing APIs, when you have to change your APIs, sometimes you get to the point where you have to version them, right? And you'll actually see that in the URI of a lot of public RESTful APIs where it'll be like, I don't know, twitter.com v2, twitter.com v3, if they've changed the definitions enough. The goal with GraphQL is not to do that, right? If something is no longer valid, you deprecate it. And because the schema for your API is always available, the tools can pick up on the new fields if they show up and ignore the deprecated fields if they don't, right? So one of the great things about GraphQL is it actually gives you some insight into how the data is structured, right? Not on the back end in the data stores, but how the schema is structured, right? You actually have the idea of the schema, which we're going to look at. One last thing, the spec is online. It's just a web page on GitHub.io. And it'll take about an hour to read. Like I said, it's 90% syntax, which you can sort of graze through. But some of the more interesting things are, the principal elements of GraphQL API, which are queries, mutations, subscriptions, and the schema itself. And we'll take a look at those. All right. So why did Facebook build this in the first place? That's a good question. If you take a look at the Facebook web application, right, there's a lot going on that page. And as I mentioned before, since it's a social network, there is a ridiculous amount of data to wade through, right? And of course, Facebook started before everybody started using their phones for everything, right? And so they had to make that transition just like the rest of us, right? They had to move from, heavy client, web-based, desktop consumers of their data to mobile, right? And mobile has its own set of challenges, right? Not to mention spotty bandwidth, high and low bandwidth, and they wanted to make sure the experience on the phone was still good, right? And lastly, they wanted to make it fairly simple, right? They didn't want to re-architect everything on their back end, right? They had invested a lot of money and time into their databases and their social databases. They didn't want to have to re-implement everything to make this work, right? So the solution was to build GraphQL, which actually sits on top of their legacy databases and solves these other problems in ways I'll show you, okay? Okay, so one interesting thing is to look at RESTful APIs again. And what I'm not going to do here today is trash RESTful APIs because they're awesome. And if you've implemented them, like I have, they work great. However, and this is particularly for mobile, RESTful APIs can be really chatty, right? And what I mean by that is, if you call a RESTful API, you might get a list of books, and maybe the metadata about the book isn't there, and you need to select one of the IDs out of the list you got back and then make another fetch, right? to get the individual book, right? And if there's related data, you might have to refetch the list and keep going. So there's sort of like this fan out of queries, right? That just blossom over time as you do more and more sophisticated things with your data. And eventually that'll collapse under its own weight and you make V2, right? And then you're sitting waiting for V3 to happen, right? When that collapses under its own weight. But like I said, one of the primary concerns, especially for mobile, is that it's not just that you're making a lot of calls to the back end, right? Which is expensive in terms of battery and compute and network. You end up throwing away a lot of the data you pull back, right? If I pull back a list of books and I'm only looking for one of them, that's crazy, right? So GraphQL is designed to sort of handle this type of workload. Okay, so before I get to the AppSync specific stuff, I'm actually going to talk a little bit about GraphQL. And as I mentioned before, you're not sending URIs to the server to get this data back. You're actually sending documents, right? So we're going to take a look at these documents. Basically, they declare the structure of your queries and your mutations. They define the structure of your data itself, your model, you know, as we call it. And it contains any one of these things, right? The schema, a query mutation, and a subscription. So just really quickly, the schema is basically your data model as it's defined in GraphQL. It may or may not map exactly to how your data is stored at the back end, right? That's abstracted through something called a resolver. But it is the structure that you're going to use to build your queries, your mutations, and your subscriptions. So a query is exactly what it sounds like, right? So you're going to send a document to the GraphQL server and say, I want these fields from this type, right? So it could be book, author, cover art, what have you. And the nice thing is, you'll only get back exactly what you asked for. So it's very network efficient in that way. And if you build things correctly, hopefully it's only one trip to get everything you need, right? Next thing is mutation. Just what it sounds like, that's when you're modifying the database. In a GraphQL implementation, a mutation is going to do two things. It's going to update the database on the back end, and it's going to refetch the data. So it's a two-step operation there. And lastly, and probably one of the most useful things about GraphQL is the subscription, okay? So declaring a subscription in your schema actually sets up what's called a persistent function on the back end, right? So if I'm subscribing to a change in the database, right? Let's say I want to know every time a book is added to my library. The GraphQL implementation will actually send me that data after it's updated, every time it's updated, which is really nice. And the way that's done in AppSync, it's actually done through WebSockets, so the performance is really good. Pretty much instantaneous, or as instantaneous as the internet allows, right? So let's take a look at some actual GraphQL at the moment. I'm going to switch over to my AWS console. There it is. Okay, everybody read that okay? This is the AppSync console. One thing to know, everything you're going to see here is standard GraphQL, except for the things I point out that aren't. Okay, so one of the other interesting things I can talk about is the client we made for AppSync for mobile. It's the JavaScript. It's a JavaScript library called Amplify. That it's open source. It's on GitHub, and it was designed to make basically writing AWS clients a lot easier. And it'll actually work with any GraphQL implementation. So you could actually use the AppSync client against any GraphQL. You can use any GraphQL client against AppSync if you want. So let's get started here. So I'm going to create a new API, and I'm just going to call it movie reviews. And there's a couple ways to do this, right? I could build it from scratch if I have the schema all set up and I want to write my own resolvers and set up my database backend, but nobody wants to do that, not tonight, right? So we're just going to start with a wizard, and it's going to do all the heavy lifting for me, but I'll walk you through what's actually happening here when we create the model. So the model is going to be called movie review model. And it already started me with two fields, right? And you can think of the model as a table, right? But we'll just continue to call it a model. It has two fields, an ID, which is required, and a title, which we're going to take as a movie title, okay? And since I am so well loved in the movie review community, I do not want to bother writing a review. I'm just going to tell you whether or not you should see it. I'm just going to make that a Boolean. Okay, so I've added another field there. This database is going to contain an ID for the movie, the title of the movie, and a Boolean saying whether or not you should see it. Okay, and that's really all I need for the model. Before I hit create, I'm just going to make those required. I'm not going to hit create. A table with that name already exists. Okay. Sorry, I was playing with it before.
You misspelled the field name too. I don't know if you're going to copy and paste it later.
This one? Yeah. I tell you, I don't mind speaking in front of people too much. I hate typing in front of people. That's the worst. I don't know. Have any of you guys gone to a conference where they do like the live code challenges? It's like those people are like, they have my full respect. It's like there's no way in the world I would code live in front of a bunch of people. But here I am.
They hand you over a mic and ask you to do the presentation one time.
Okay, let's try this again. All right, and now we're going to create the resources, and we're just going to say, I'm not going to take any chances on that. Okay. All right, so what is it doing right now? The first thing it's doing is taking a look at my model. And this wizard just happens to put everything in DynamoDB, which is AWS's key value data store. It's a NoSQL database, okay? The other things it's doing is creating resolvers. And in the GraphQL spec, a resolver is basically the glue that ties the Graph API implementation to your data backend, right? In some GraphQL implementations, they're written in a certain language and they expect the resolvers to be written in a certain language. With AWS, they did something interesting with the resolvers I'll show you in a second. But basically what they've done is they've taken my model, implemented it in DynamoDB, created resolvers that'll insert and fetch data from DynamoDB, and created a schema for me. Okay, so let's take a look at this schema really quick. Whoa. So one thing I hate about this interface is it's really hard to get. There you go, maybe that's a little better. Okay, so our schema here has a couple things. Let's start with something familiar, right? So we created a model called movie review, and right here you can see there's a type called movie review. So there's a couple ways to look at that. You can call it an entity, a model, an object, it doesn't matter, right? It's a model inside GraphQL that's going to have attributes associated with it, right? So we have ID, title, and see it, which are the three fields I put in. The exclamation point just means it's required, okay? And based off this little bit of information I gave it, it actually did quite a few things. It created CRUD mutations for me, right? Create movie review, update movie review, and delete movie review. And there is the R part of the CRUD, the query, right? Get movie review, okay? So the syntax for this is pretty straightforward. Following the colon here, this is the return value, right? So when you make this mutation, create movie review, you will get that movie review returned to you from the server once it's modified, okay? The input parameters, I should talk about this a little bit. What AppSync does for you here when it auto-generates the code, it's actually using a best practice, which is they say make a separate type for your inputs and a separate type for your return types, because it makes it a lot easier to read, it makes it a lot cleaner, right? And makes it a lot less, makes it a lot easier to maintain, I guess is the way to put it. Of course, it also makes your schema a lot longer. So let's take a look at what one of these input types looks like. Let's see. So there's the create movie review input, right? It's just another type. It's specifically called input. That's a keyword. And when I modify movie review, I'm just going to pass it the title and see it, because I will already be referring to a specific, well, this is a create, right? So it doesn't have an ID yet. It's smart enough to know it needs to generate an ID for you, right? And delete, you don't need anything but the ID, right? Because you're just deleting a certain instance, and it works that way. One question people have about this as a query language, it's different from things like SQL in an important way, because SQL builds in certain operators like sort and group by and a bunch of other things that have to do with the shape of the data, or filtering the data, or sorting the data, that sort of thing. GraphQL doesn't do any of that for you, right? Basically, what you're saying is, give me this data. This is the data I want, just give it back to me. If you want it sorted, if you want it filtered, this becomes an implementation issue, okay? So in our case here, you'll see there's actually an input called table boolean filter input. And the way that works in this implementation is this. Let me find a query that uses that. Okay, so for example, here's a query called list movie reviews, okay? If I didn't give it any parameters, it would just dump the whole thing back in my lap, right? Because I didn't filter it at all, okay? So fortunately, the code generator was smart enough to give me two tools here as parameters. I have a filter, and I also have a limit, okay? And the third thing I have here is for pagination, okay? So I can filter based on some value, I can limit the amount I want returned, and if there's 1 million movie reviews, because let's face it, they're not that hard to write. If there's 1 million movie reviews, you'll paginate through it with the next token string as a parameter. But once again, I mean, this was done automatically for me just because I used the wizard. But if you're going to create a schema from scratch, you will have to implement this yourself, right? And in keeping with input types here, the table movie review filter input, right? Let's see, is right here, right? So there's going to be a filter input for ID, a filter input for title, a filter input for see it. And there's 3 different types because ID, title, and see it are literally 3 different types of data, right? And a number, a string, and a Boolean, okay? So that's something else about GraphQL schemas and definitions that's different from, let's say, JSON. This sort of looks like JSON, but not really, because it doesn't have commas between the fields and things like that. But more importantly, everything is typed here, okay? So, for example, if I want to filter on a string, I would use table string filter input, and then it just says there's a parameter called not equals, and then I provide a string, like not equal to Terminator's movies, right, or whatever it is you don't want to see. And that brings up another interesting part of GraphQL is the definitions are hierarchical, right? Not just in a data format. You can certainly have nesting inside your model, right? Which allows you to have some pretty complex schemas. But you also have this idea of hierarchy inside these input models as well. So the first time you look at this, especially the auto-generated stuff, as you can see, it generates a lot, quite a big schema considering how much information I gave it. These queries can get pretty onerous. I'm sorry, the schemas can get pretty onerous, but there are actually some good tools out there to help you, sort through them, right? So that takes care of the schema piece, right? This is what we've actually defined in our database. So you may be asking, well, that's great, but how does it actually pull data from the database, okay? And as I mentioned before, that's the job of the resolver. That is something that's specified in the standard, but they don't tell you how it's implemented, right? Because it's not an implementation spec. So I'm just going to take a look at here in create movie review here. There's a resolver that was already built for me, okay? In this interface, it happens to have the name of the model, right, which is the movie review table, which was created for me inside of DynamoDB. And this is an interactive editor for the resolver. And the way AppSync does resolvers, which is unique to AppSync, this is not part of the spec, they create two templates. And we use the velocity template language for this. And if you're familiar at all with DynamoDB, you will see that this template looks a heck of a lot like a JSON command for DynamoDB, because that's exactly what it is. So if you're not familiar with Dynamo, take my word for it. When you update or create a record in a Dynamo database, it has this JSON format here. In this case, create is called put item. And it's using the template language to pull out the fields from the mutation, if that makes sense, right? So think about it this way. When you send that document into GraphQL, okay, the GraphQL engine is going to figure out the resolver for that mutation, and it's going to pass that document into the resolver, which is what's happening here. So AppSync is taking that document, using the template language to extract data, and then issues a command to DynamoDB, which updates the data. And that's on the way in, right? As I mentioned before, every time you do a mutation, GraphQL is going to give you a response. So in our case, the return is pretty simple, right? Again, it's just velocity format here. It's taking the context result from the DynamoDB command, converting it to JSON, and sending it back to the database. And the database then is going to put it in the correct format that matches the shape that's in the schema. So you can think of this as sort of like a two-step process, right? And basically that's how it's done. Because this is your code, right, and whether you use AppSync or not, you're going to write resolvers. Because this is your code, you can do anything you want here, right? You can call public APIs, you can call a bunch of different APIs and do calculations and logic on it. It's pretty much up to you. Of course, the trade-off is performance, right? You just want to make sure if you have a high performance implementation that you make these as efficient as possible. For AWS customers, a lot of them do use Dynamo just because it's pretty quick, and mobile data is a good fit for NoSQL databases in general. So this type of template I just showed you is pretty popular with our customers. A couple other things about AppSync. The resolvers are always going to be velocity templates, but we also have the ability to talk to different backends, what I call natively. It's sort of like built in. Dynamo is one of them. Elasticsearch is another backend you can use. You can actually point to an HTTP endpoint, which is useful if your AppSync implementation actually fronts a RESTful database. A lot of our customers who are moving to AppSync from REST are just putting AppSync right in front of their existing legacy databases, even if they're only 6 months old, right? So, so that's useful. And then, of course, if you're familiar with AWS at all, everything has Lambda, right? So the fourth type of resolver is a Lambda resolver. And that actually allows you to do some interesting things too, because Lambda itself, you can write that code in a bunch of different languages, everything from C# to Node, Python, Ruby, Java. It gives you a lot of flexibility. The other thing you can do, you can see from the template language, there's a context here that contains a lot of data, including a lot of data about the original request. Like for example, if you wanted to pull a JWT token out of the context and use that to authenticate a downstream call, you can do that, right? We just had a customer who was asking about that the other day. So the trade-off is, yes, you have to write these, but the flip side is you can do anything you want with them, right? Even if it has nothing to do with the database. One of the things AWS is doing, obviously, is trying to build these resolvers for as many different data types as we can, because there's a lot of people who, a lot of people have very strong attachments to their existing applications for some reason. So we try to make sure there's resolvers and features that match, relational databases or any type of database they happen to be using. Okay, so that takes care of the resolvers. Let's do something with the database now. So I'm at the query pane now, and what I'm going to do is create a movie review. So down here, title, Terminator 1, yeah, you should see that. That's a good movie. So I'm going to do create movie review. And that sends a query to the back end, and here's my response, right? So you'll see I sent in the title and the see it value, and I got back what I put in, which is good, right? Because basically it doesn't write to the database and sends you back what the update was. And it also gives you an ID, right? So now you have the ID to work with. Something interesting about GraphQL IDs, especially in relation to REST APIs. One of the great things about a REST API is if you have the URI that pulled a record out of your model, that's pretty much a unique, that's like a unique key in and of itself, right? So you lose that when you go to GraphQL, right? Because unless you put an ID field in there, we don't pull things by ID, right? There might be a collection on the back end, right? Like these movie reviews, and I might say, just show me all the ones that where see it equals true. You could get back, 500,000 records, and unless you put an ID there, there's no way to really identify them, right? You have the data you asked for, but this issue of uniquely identifying them is up to you as an implementation detail, right? So that's one reason we have like the very long IDs, hopefully globally unique IDs, which is great if you're going greenfield, right? If you're writing everything from scratch. If you're writing on top of legacy implementations, you may have locally unique IDs, right, with your data. In which case, the recommendation would be use both. Like, make sure you're tracking the locally unique ones for the data source you're using, but make sure you also apply globally unique IDs to your data as well. And that's something that, like I mentioned, it's not addressed in the spec. It's something you have to figure out and implement yourself. Let's see, I'm going to do at least one more. What's another movie everybody should see? Anybody? Avatar?
Aviator?
Aviator. Oh, okay. That was the Howard Hughes movie?
Yeah.
Yeah, that was cool. That's a good movie. All right. So I'm going to do the same thing. I'm going to create another movie review. And just give me one movie review that, movie that's terrible. Just do that. That's a pretty safe one. Like usually I don't like calling out movies, but even people who love that movie agree it's like a bad movie. So. All right, so now I have 3 movie reviews in the database. If I wanted to list them, I would call this, right? Here's a query, and you can send this to the server as a document. If I was going to list them, I would get back, here they are, the room, Terminator, Aviator. Good, we got all our data back. And let's say I'm formatting this for display, and I don't care about the ID. I just take that out of the query, and you can see I'm only getting back what I asked for. And that's, even though that's a really simple demonstration, you can see how this could be really useful, especially if you have these really rich data models. It depends on the efficiency of the implementation, but luckily doing all that orchestration of the data and filtering, or at least this level of filtering where you're filtering out the fields you don't want to see, is done for you automatically, which is nice. As I mentioned before, it also makes it extremely useful if your data model changes a lot, right? You can put like little annotations next to the fields, like for deprecation, and tools are smart enough to know, you know what, if this field is deprecated, I'm not going to show it in the tool and not make it available for querying, that type of thing. And obviously client APIs can do that as well. So we've taken a look at queries very briefly. We've taken a look at mutations and the ability to create these things. One thing we haven't taken a look at yet is subscriptions. So let's take a look at what the subscriptions look like here. Okay. So I have a bunch of subscriptions here. If I had a real-time application, whether it was mobile or web, how are we doing on time so far?
We have another 17 minutes.
17 minutes, okay. So, so for subscriptions are kind of interesting, right? So if you have a real-time application and you want to be notified every time something changes, subscriptions are attached to mutations, which kind of makes sense, right? If you're going to modify anything in GraphQL, you need a mutation. So if you want to be updated on changes, you attach a subscription to a mutation, right? So if you take a look at the syntax here, subscription is a type, just like query and mutation is. I want to be notified every time a new movie review is created. So I created a subscription called On Create Movie Review. I'm telling it basically what fields I want to see, which also means what fields are changed. Now in create, it doesn't matter that much because all the fields are changing because we're creating a new instance. But let's say you have a mutation with a large number of fields and you only want to be notified when a certain field updates in that record. You can do that as well. That's really powerful because it gives you a lot of control over what you see and what you don't see. There is, obviously there's something AWS specific in the definition there, right? Where we have the @AWS subscribe. That basically just says which mutations this subscription is tied to. In our case, it's create movie review. So before, when we were creating movie reviews, if we had a subscription on our client, AppSync would open up a WebSocket to us as soon as we instantiated the subscription, and we would get the data as soon as it was updated. And actually, that's a really non-trivial thing to do when you think about implementing a spec like GraphQL, because as I like to say, everything works at a small scale, right? Anything will work, right? If you only have like 10 subscribers with like 500K of data, it doesn't matter, right? Everything will work fine. One of the things we're doing as AppSync gets more popular is people are wanting to use it for more and more demanding use cases. I think when it first came out, well, obviously Facebook had it, right? And they certainly had a large number of clients, but the data load wasn't necessarily that high, right? Or at least their data load got a lot lighter once they moved to AppSync, right? Because they weren't making all these REST calls all over the place and fetching megabytes of data and dropping it on the ground, right? So once they moved to AppSync, they actually got a lot more efficient, which was the whole idea. But we're starting to see customers who want to use it for all sorts of things, like real-time stock price tickers for trading apps and stuff. And I'd like to say there's no reason you can't use it for that, But there is a reason, and the reason would be how much horsepower do you have and how much latency are you willing to put up with, right? So, not surprisingly, at AWS we have huge data centers with lots of hardware behind it. So, you know, we feel we do a pretty good job with that. But there's always a customer who wants it faster, right, with a little more latency. So whether you're doing this yourself, whether you stand up a GraphQL stack on your own or you're using a cloud provider, there's going to be basically two things at play, right? And it's what we call fan out, right? So it's going to be the number of clients you have, right? Whether it's 10 or 1,000 or a million, the amount of data or transactions per second you expect to happen, and then the latency, right? So one of those, you know, if you're flexible with one of those, you'll probably be okay. But if you want like 100 millisecond latency for 1 million clients with, you know, I don't know, 512K a second coming across the wire, that's going to be an issue, right? So that's kind of the space we're in now, I think, in the industry too, as we're learning how to use AppSync and we're working with customers, is you know, trying to fit the right use cases for this particular technology. The good thing is the more popular it gets, the more resources we can put against it, right? So I don't know, that's just something I thought was interesting, having, you know, built some of these solutions out there.
I have a question about
Sure.
the subscriptions. You were saying that you could have different fields on there, and I'm thinking of two things. First of all, like I might want to subscribe only to the movies that you've tagged as see it, for example. So would that be a different mutation, or would that be a different subscription?
It would be the same mutation, but if you wanted to make that, it would be a different subscription if you just wanted to see that, for example.
Okay.
It's sort of like, think of it like as a conditional subscription, but the mutation's the same.
Yeah. Okay, so then that probably answers the other question, which is that if you wanted, you said that the outputs, the columns there, those would be the outputs from the subscription. So if you had like one person that one kind of subscription that wanted more fields than the other, then you've got two separate subscriptions.
Right. Yeah, let me go back to the presentation for a second because I want to show you something on the subscriptions really quick. Talking about that. Okay. Here's just some sample code from the Amplify client. As I mentioned before, Amplify is an open source JavaScript client. It's not just for GraphQL, but it includes a GraphQL client that you can use for AppSync or any other client. And what's interesting about this, although you can define your subscriptions in the schema, right, you know, at model definition time, GraphQL is actually, you know, a living, breathing query engine, right? So in this case, right, the code I'm showing you, this subscribe to events, you can actually generate unique subscriptions from the client, right, and send those up to the server. So in this case, what I'm doing is I'm creating this subscription definition, which is a GraphQL document, right, called subscribe to events. And then I can use Amplify in this case, or the client of your choice, to send that operation to your GraphQL server. So in this case, it's a GraphQL operation, subscribe to events. Basically, you're sending the document to the server at that point, and you're hitting subscribe. And in this case, it's a JavaScript implementation. Every time you get a hit on the subscription, that next function will be called in your code. In this case, we're just dumping it out to a log, right, because it's sample code. But the cool thing is here, it's not just a question of sending like queries or mutations to the back end. You can actually define new subscriptions, cancel subscriptions, you know, handle pretty much your entire interaction with the database that way. Okay. All right, what else can we talk about AppSync? So AppSync is a managed service, right? It's part of what we call the serverless suite, and I know that's a funny word. Obviously, we have tons of servers. We're not hiding them. We're not pretending we don't have them. But usually what we mean by serverless is It's not a server you have to worry about, right? And frankly, a lot of the solutions we're seeing, especially with newer customers, if you're familiar with cloud at all, right, there was sort of, what was called Cloud 1.0, which was sort of lift and shift, and then there was another generation of cloud, which was building infrastructure, right, compute, network storage, and putting all your software on machine images and loading those on the VMs and running them, right? There's still an enormous amount of customers that use the cloud that way. But a lot of customers now are starting to move more toward serverless, which is a paradigm of configuration over code, right? And the idea there is, since the cloud is able to manage these services for you and keep them running and patch them and make sure the network doesn't go down, right? You can focus all your energy on the code. And I just had a customer ask me yesterday, he said, so what's the distinction between like configuring these services and writing code for them? And I'm like, exactly. As we move closer, further into this paradigm of serverless, the distinction between writing code and configuring the services is going away, right? Which can be a little challenging for things like CI/CD or your DevOps folks, right? Because in an infrastructure model, it's very clear what the IT guys were in charge of, what your DevOps guys were doing, and what your software developers were doing, right? As we move into serverless, we'll just take a look at the schema. Like, is that code? Yeah, I guess, right? You can put it in a Git repo, right? You can deploy it, and so hopefully you get the picture of what I'm trying to say here. It is a challenge, and frankly, we're trying to move that direction because it becomes a lot more efficient for our customers that way. Job roles aside, we're finding that people can spend a lot less time, taking care of the solution and more time developing solutions, right? Doing more value-added stuff for their customers, which is kind of the point. So we've been working really hard, making this a managed service, making it easy to connect to different types of data stores. Security, we haven't talked too much about that yet. The security story is pretty typical for an AWS service. You can use what we call SIG-v4 signed URLs to get in there. We have a solution called Cognito, which is an identity pool and identity federation service. You can use things like OAuth or OIDC, JWT tokens, that sort of thing to get in there. And I can talk about all that stuff later, but that's a rabbit hole. Security is always a long conversation. But we have lots of it, and it's good. Okay, so in our case, AppSync, like we mentioned before, we have the implementation running. It's a managed service, so it's what they used to call multi-tenant in the old days. So customers share the same infrastructure, right? And which allows us to scale and keep it up all the time. Let's see what else we can talk about. Mixing and matching data sources. We talked about resolvers here, right? Where you could have a single query that queries multiple resources, or a single mutation that changes multiple resources. And the subscription model is really, really powerful in GraphQL. And this slide just basically says, the way you used to do subscriptions, it's sort of a pub/sub type model. And if you're going to roll this yourself, right, you have to take care of not just the architecture, but also the fan out and how you're going to manage that data. And it becomes a really challenging problem. When I talked to the AppSync team on this, they said they spent more sleepless nights getting subscriptions working the way they wanted to make sure, it stayed up and the performance was good and it handled the scale and that sort of thing. So, GraphQL for mutations and queries seems a little vanilla sometimes because it's like any other database in some ways, but the subscription part is really substantial. So regardless of the implementation you choose, just make sure it supports whatever your use case is. Okay, we talked about that. Just want to get to Talking about security again, one other thing you can do with mutations, other than orchestrating the data, is you can actually do some access controls in there as well. And it allows you to do filtering based on context values. So, like I mentioned, when you go and mutate a service or even read a service, if someone's not allowed to do something, you want to prevent them from doing it as soon as possible, right? So, one option, right, you can block them at the front end, right, and keep them from accessing AppSync to begin with. You can block them in the resolver here and keep them from actually accessing any data stores, or you can block them at the data store itself, right? If, let's just say there's a, there's some security credential that, IAM or some other security mechanism prevents them from doing that. The one thing I would say though is a lot of customers prefer to keep the middleman very efficient and very small. I've had people say, I don't want to learn velocity templates. I want to keep those, I don't want to learn a new language for anything, right? I just want to write the code and keep the resolvers as a pass-through, which is fine, which is great. You can do that too. Some other things about the client. The spec doesn't really talk about caching, okay? It basically says what your GraphQL implementation will do, but one of the things we found, especially for mobile applications with spotty reception and low bandwidth, it really makes sense to have that data on the device and cached. So if they drive through a tunnel or they're on a subway someplace, they still have access to all their data. And the AppSync client that's an Amplify will cache that data. In fact, when that client writes the data, it writes it to the cache first and then updates the database. Even more importantly, if you lose connection, it will know that you lost your connection and cache those updates for later, so when you regain connectivity, it'll push all that stuff back up to the back end. That's the second largest thing that the developers said that kept them up at night, was writing the code just to manage the connections and queue up the data and make sure. So there's a lot of really useful things that are in the client, the caching, the offline updates, that sort of thing, that you don't have to write yourself, which is really nice. So I think I'm running up on time here. I got through everything I really wanted to. Last thing I should mention is Amplify again. If you want to play around with this, the AWS console, which I just showed you, is a very friendly interface. It costs almost nothing to use it, right? It costs me nothing. I have a waitlisted account, which is the best part about working at AWS, by the way. I can build whatever I want. So there are also other clients you can use. There's UIs that look exactly like the AWS console, where you have the schema and a query and query parameters and a return. We'd love you to use AWS for this, but if you don't, it's a great open standard, very exciting, lots of customers using it. And thanks for paying attention. I know I'm up against time, but I'll be around a little bit to answer questions. That's it.
We'll take a quick 5 minutes break, restroom, and to get something more to drink and eat, and then we'll get back in 5 minutes. Hey, how are you?
Yes. No.